Okay, so alright, yeah. Okay. So, um, last week we had this. It's just like the square, and it's like just moving off the screen. Let's actually like make that a little bit better. Show you guys a little trick to make just like, because right now we're just using like these rectangles and stuff that are like built into Pygame. So let's like make it a little bit more pretty to look at, because we're gonna be staring at this cube for quite a while today. So first thing is, if you go onto, let me share my screen. Share. Alright. So, if we go onto our player, I think I didn't show it. Here you go. This is what we had last week. We just have the square just moving to the side. So let's make it a little bit better. So what we can do is pygame.draw.rect and put on the screen, and we can put in a color. We're actually gonna define a new color up here. Just call it outline color, and we're gonna set it to a value that is slightly darker. So we're gonna use a smaller value, because 0, 0, 0. That means we're putting in no red, no red, no green, no blue. That will give us pure black. So we want this to be slightly red, but a bit darker than this one. So it'll give it kind of like an outline effect, right? And we can use the same rect, exactly the same this, but we need to put in one more parameter, and that parameter is going to be the width. So we can make it another variable, so outline width. And we can just define it up at the top here, outline width, and we'll set this to 3 pixels. So just make this pretty. If we run this now, boom, it's got an outline. And we can like fiddle with these values. Like, let's say we want a big outline. Yeah, it's gonna completely cover the entire thing. Let's make that just like that. There you go. So I fiddled around with these values, and I found that 3 kind of looks nice with the vibe I'm going for. So yeah, that fixes that. Now, you've probably noticed if you're using PyCharm, it's got like all these like little squiggly lines here. They're like in this like brownish, and what they're basically saying is that it's not really following like the good coding like principles to make your code look clean. And that's just like all these extra spaces here. You can like do that manually, but the good thing about PyCharm that I like is if you right click on any of these like brown squiggly lines and hit show context actions and reformat the file, and then it'll fix everything, and it'll even fix it for the other files as well. Okay, so that's just a cool thing. Fix show context files, reformat the file. You can also just do it on the entire folder. So you right click on the folder, reformat code, and you can optimize imports, clean up code. Yeah, that's usually what I do. And it'll just go through all the files, and it'll add like spaces after your commas. It will make sure that there's only one blank line at the end of each file. Just a really, really cool thing that will kind of make your code look a lot cleaner. And of course, nothing changes, it still works, right? Remember to always check that your code still works. Okay, so we have our thing here, and we're going to now add in like tiles for our player to kind of stand on, and we'll be doing collision, so that's going to be pretty interesting for you guys, hopefully. First things first, like right now we kind of have our player and everything, like it's all inside of the main loop here, and since we're kind of going for like multiple files here, what I'm going to do is I'm going to make an entire file that will like contain everything related to the game. And the reason that we're doing this is because we're taking advantage of the fact that you can make an instance of a class, right? So we have a player class here, right? This is for a completely new player. It'll make a new player every time you make an instance, and you make an instance by putting these parentheses here, right? This P is different than, for example, P2 equals player, right? These are completely different players, right? So what we can do is we can create a class for a game, right? Everything that's related to the game will be in that class. So every time we make a new instance of that game class, we'll have an entirely new game. So why do we want this? It's useful for one thing, or two things actually. First thing, it'd be really easy to reset everything. So if you want to, like, let's say your player dies, then you want to reset the entire game. And of course, you could like go through like every single thing and set it back to the default value. That's like too much work for anyone, right? Like, as soon as you add something, now you have to put something back in that reset to reset it again, right? So what you can do, just make a class for a game, and every time you want to restart the game, so your player dies or your player wins, you can just set game, the game is equal to game, right? The game class. Okay, second thing, we're gonna be making like menus and all kinds of like other menu GUIs and shops and whatever, level selection. That can all be done in like a different scene, right? So if you have like, for example, your game, that's one scene. We're just calling it a scene for now, right? We have a game that's one scene. Let's see, your menu, your main menu is another screen, and level select is another screen. Right? We can easily switch between those screens by using an instance of a class. So let's actually put this into practice. So make a new file, and we're gonna call it game.py. And from setup import star, we're gonna put that every file. We're gonna make a game class. So we make an init file, right? An init function, and the next thing we need is an update function, and we take in delta time, and finally a draw function, and it takes in the screen as a parameter. Okay, so this is going to involve a little bit of copy and pasting, so I'm just going to move this file to here. So I have game.py on this side, and I have main.py on this side. So what I can do is I can kind of just steal some code from this one and put it straight into our game class, and then we'll be running these functions like update and draw instead of like doing like two things at once here. All right. So first things first, I'm gonna steal this player. We're gonna say self.player is equal to player. Right. We need to import that, so we can steal that. Alright, so I just moved like the entire player thing to here. So let's take everything related to the player. So every time we update the game, we're going to update our player. So self.player .update, and we're using a variable called delta instead of delta time here. It doesn't really matter what it's called. And oops. Next thing, self.player .draw, and we'll draw it on the screen. Okay. So we also want to take in this screen.fill, because we might want to have a different background color in a menu or something, so we can just steal that and put it into here. The next thing we can steal is this event loop. Like, we might be checking for different events if we're in a different scene. Like in your menu, you probably don't want to be checking for WASD, right? Because that's not controlling the player in the menu. There's no player in the menu. And then yeah, we've kind of like stripped this down here. Let's make sure that this still works. So let's import in our main file from game, import the game class. So that's our game class right here. And we want to say the scene is equal to the game. So we're calling a scene here. Okay, so we want to keep delta time here. Delta time, that's going to be the same for everyone, for every scene, so it can just stay there. And we want a scene to update, and we want to pass in delta time, and we want a scene.draw, and we'll put it in the screen. Okay. So this is a lot cleaner now. It's easier to see where everything is going, especially if like you've never seen this code before, right? You can tell, okay, yeah, we're gonna update our game here, right? And then we're gonna draw our game. Okay, but it doesn't work when we run it, right? It doesn't work. We had that issue again where it doesn't close. Like I'm clicking this and it doesn't close. So what you need to do is, like, when you see an update, we look at every event and we're saying is running is false, but this is running is not the same as this is running, right? This is local to this function, this method right here. Okay, so it's not going to affect this is running over here. So what we need to do is we just need to return something. So we want to return, but what do we return? Okay, let's go into our setup file, and we're going to specify some commands for our game, right? So we have command, command, and quit is going to be equal to 0. So what we can do is we can return command quit, right? This is in setup. In setup, we have this like constant variable, and we're saying we want to return quit. And the reason that we're putting it in setup is because we've imported it into every file. We know what we're talking about, so we can say status is equal to this. If the status is equal to command quit, right? This will be the same as this one, right? So when we return command quit, we get this. Then we want to say is underscore running is equal to false. If we run that now, there we go. It will close. Perfect. So we can also set up some other commands just for the future. So some of them we'll have is command restart. We'll just set that to 1. Command next level. We'll set that to 2. And we'll just make one more in advance. Player dead is equal to 3. Okay? So these, we're just going to be kind of saving them for later. We're not going to be using any of them yet. Okay. So that's our main loop in our game. Let's go test it out. Make sure it still works. We can go out of the screen. When we click the X button, it will close the window. Okay, great. So now we have like our game here, and we can reformat the file just to make everything pretty. Okay, so we have this game, we have a player. Let's add in some tiles. So make a new file, call it tile.py. Alright, so tile.py, we're going to need from setup import star. I'm going to copy all of this stuff from setup. And then here, we're going to make a tile class. And we need to know a few things about our tile, such as the width and height. So I'm just assigning 2 variables at the same time for the width and the height. Both are going to be 50. And then our color, we're going to make the tiles black. And we're going to make the outline color into 150, 150, 150. So if 0, 0, 0 is pure black, right, and 255, 255, 255 is pure white, then this like value is kind of in the middle, not quite. It will be like sort of grayish, right, because we have 150 on all of them. Like just like a general tip is if all the numbers are the same, it's probably going to be gray, like kind of like a light gray or dark gray. Depends on what value it actually is. And one more kind of thing to put in here, outline width is also going to be 3. And you kind of want to keep these kind of like styles consistent, like just to make your game like look polished. Like if you have like different styles, like here we have like outline width of 3, right, for our outline. This one should also be 3 as well, just to make it look like they're like a part of the same world. Unless like that's the kind of effect you're going for, but you need to be pretty experienced to be able to do that, to pull it off well. Okay, so in our tile, we only want to know one thing when we are making a tile, and that's where should we put it. And we'll say the position is equal to pygame.vector2 of the position. So we've made a position of vector2, so this will just store the x and y components of this position. Position is going to come in as a tuple like x, y, like that. So Pygame will help us store that. Next, we want to update. I misspelled that. And we want to take in delta. And we also want to take in how fast is our camera going to be moving, because our player is not actually moving, right? Like our player he's moving, but the ground is moving. Like what we want to do, instead of like moving the player forward, we want to be keeping the player still and making the background move back behind him, right? Like if I were to kind of show you guys in Paint. So let's say I have the ground like this, right? Or no, I'll draw my player first. So we have our player here, and we have our background like this, right? If we want to give the illusion that the player is moving, but we don't want to be moving where he actually is on our screen, right? Like if this was a game, then it would be moving like this, right? It'd be moving the background back, and maybe he wants to jump. Look, all I did is move the background, okay? So take a look at that again. I'll make this longer even. So it looks like the player is moving, even though all we're moving is the background. And if he wants to jump, same thing, right? So that's essentially what we're doing here. And we're giving like a camera speed and all of that stuff. So for our camera, self.position is just going to be subtracting the camera speed times delta. So speed is just going to be pixels per second, delta is our time in seconds, and our position.x, we're only going to be moving it like side to side, so we don't need to worry about like moving it up and down because the player itself will move up and down. Okay, and last thing, draw. So self.draw and our screen. I want a pygame.draw.rect. I want to draw a rectangle on the screen with the color that we chose. I want to draw it where the tile is. So the tile is just going to be like exactly how we made our player, where we define the top left corner of that player as like its position. So, and we're just like assuming everything goes out like to the bottom right. That's kind of how we're doing the same thing for our tile. Right, I'll show that again. So like if we have a tile, right, then we're just gonna assume that this is the coordinate and that it will always go this way to make a full tile like that. Okay, great. And then we can just literally highlight this entire line, and you want to hit Control D, or it might be a different one, it might be Control Shift D. Just depends on whatever your settings are. If it doesn't work, you can just copy and paste it onto the next line. And all we want to do is change outline underscore color. And we want to add a width. So self.outline width, right? So like, you see this line here, this line right here. I don't know if it shows up in the meeting, but basically you want to keep your code like less characters in this line. And if it does, you can just like move it on the next line if it's inside of parentheses. So it just like looks a little bit nicer rather than having like a super massive line of code here that you need like those like stretched out monitors to be able to see. Anyways, yeah, this is our tile. This is everything that we will be needing, so we can just like move this out of sight. Okay, let's go back to our player, or sorry, our game class, and from tile, import the tile, and we want to put this tile in list of tiles that we'll be having, and we will be making sure that we update this list so that our tiles are appearing, so that they like will move. And the second thing is we want to draw our tiles. So that's two things we need to do with our tiles for every single tile. Okay, how do we keep track of all these tiles? Well, we use something called a list. I'm pretty sure you guys are familiar with. And in this list, we want to put in a tile. And for now, let's just put in the position like screen width divided by 2, screen height divided by 2. And we'll set the self.camera speed is to a pygame.vector2, and we'll put it as like 300 pixels per second. And then here in our update function, what we can do is after we update our player, we just go in our list and for tile in self.tiles, tile.update delta and self.camera underscore speed. Did I misspell that? Oops. Okay, so in your tile, make sure this is a tuple. So put an extra set of parentheses in here around this. Okay? And then we need to draw it, so we can literally just like copy this. And we do want our tiles to be drawn on top of our player. So we're just gonna, instead of update, we're gonna change this to draw, and we're gonna put in the screen parameter instead. Okay, so this should be everything, and you should see that we have an error. Okay. Oh yeah. When you are in the game, make sure you pass in camera speed.x. There you go. There's our tile. But right now, our player is also moving, so let's make sure he's not moving so we can better appreciate that. There you go. So our player is now, you can now see our player is staying in the center of the screen, but this tile is moving backwards. Let's do like a little change. Let's make the player like where we're actually gonna put him. So we're gonna put him at a fifth of the screen width. So I'll just show you guys. Actually, I think you guys can understand. We're just putting him as like a fifth of the screen width. Right, this is like 1/5 of it, and this is like 2/3 of the height. Because right, it starts from 0 and goes up this way. I think it's better if I just take a snip of it. There you go. Okay. So, right, like this is like, if we take like this area here, right, this is about a fifth of this entire thing, right? 1, 2, 3, 4. So it's about that, approximately that. And then for this one, like let's say it's like this, right? This is where we're putting it, 2/3 of the screen height. Okay, and let's close this. Okay, that's very nice, but I actually want to like see more tiles, right? Just to like make it look better. So instead of putting it at the screen width and screen height, why don't we put it like, we make like a row, like a floor almost, of tiles. So we need 2 parameters. We need to put in like an x and a y. There's only one argument we need to put in. And we're going to use something called list comprehension. So just like look at what I'm writing here for a second. So I'm going to use I and we'll do screen height minus tile.height for I in range 0, comma screen width times 3, comma tile.width. Okay, so I just wrote out like a whole bunch of things in here. So I'm going to break it down step by step. So if you look at this, we're using a for loop, but it's like inside of a list. What this is essentially doing is saying we're taking this, so alternate way that is the same as above. That's essentially saying this, and then we'll have like self.tiles equals this, and we're just gonna append this. Self.tiles.append this. Okay, this is exactly the same as this one-liner right here. But of course, what's better, this one-liner or like 3 lines? I'm gonna go with this, obviously. So let's break this down. So we basically just rewrote this into 1 line. But now what does this actually mean? We have for I in range 0, screen width times 3, and tile width. So the range function can take in like different amounts of parameters. Like usually you're probably familiar with using like for I in range like 10, and that'll print out the first 10 numbers, right? Let me actually show you. If you go onto scratches and consoles here, you can make a new scratch file, and just type in py on, right? This scratch file is entirely different from your project. Like as you can see, this is different than here, and you can just like run any kind of code you want here. So like, for example, for I in range 10, print I. Like, this is just a useful way for you to like test some code. So we have printed all the numbers from 0 to 9. Let's say you wanted every second number, right? What you can do is you can set the starting number is 0, the ending number is 10, and the skip amount, how much you want to go up by, is 2. So normally, so as you can see, we start at 0 and we skip 2, and that's just how it works. So this way we can analyze what we've done here, and what we've said is we want to start from 0. We want to go up to 3 times our screen width. So we're making 3 screens worth of floor, and we're separating each amount by the tile width. So this way it will give us like exactly 1 tile, and then immediately after it will be another tile, right? And it won't have like any overlapping tiles. Alright, and last line, we're just appending, so adding to the end, a tile, and we're putting it at the x coordinate. So this one is already accounting for the width of the tile, as you can see here. And we're doing screen height, so that's the bottom of the screen, subtracting the tile height. So that's just going to put it so that it will be exactly at the bottom. So let's actually look at what we've done. So make sure you're running the right file, so run main. And game object has no attribute camera speed. Did I put this in the wrong file then? I swear I made a... Okay. I guess the mind is playing tricks on me. So we'll just make camera speed equal to pygame.vector2 300, 0. I think I actually deleted it before. Oops. But there you go. Tiles at the bottom, and they're moving past us. Cool. Cool, cool, cool. Alright, let's look at it again. As you can see, the player, like if you like don't look at the bottom, player is not moving on the screen, right? But you put in, once you put in the bottom, right? Now you can see it's moving. It gives the illusion that it's moving forward. Anyways, that's cool. Let's add in our player's gravity. So we do have gravity here on our player. We just didn't add it. So in our player's acceleration, we'll say he is being affected by self.gravity.y. Now the player falls. But now our player falls through the entire map. He's just like clipping through it. And what we need to do now is we need to actually like do collision detection. And we just have enough time for it, I think. I'm going to show you guys a quick presentation, and yeah, hopefully we'll be able to implement it. So we have a slideshow here. You guys see it? Yeah, okay, good. So we're going to be using a technique called axis aligned bounding box collision. And this collision detection method is pretty useful for squares because you'll see for reasons. So the reason that we want to use this is because it's very basic math. So like it'll be like a very quick calculation. You can use it for our 2D game, Geometry Dash. Yeah. So for example, we have like games like Mario, and I don't know if you're making like 3D games. This can also be useful, because the concept does still apply to 3D. So here it is. So we have a series of 3 diagrams here, and if you see here, if we have no axes that are overlapping, so like an axis would be like this is like the x-axis and this is the y-axis, right? Since this one is not overlapping with this line right here, that means there's no overlap, and this line right here is not overlapping with this line right here, that means there's no overlap. Okay, let's look at this second diagram right here. Can I use the laser pointer? Awesome, yeah. Okay, so we have this bottom axis right here, and it is going right through this red square, right? This one is also going through this square. So there's one axis that's overlapping, right? You see this line right here and this line right here, they are not overlapping. They're not under each other. They're not going through. Like if I were to extend this line out infinitely, it's not ever going to touch this one, right? finally, we have two axes collision. So when there's two axes that are colliding, so as you can see, this axis right here is colliding with this square. This axis right here is also colliding with this square. That means that we have a collision. So that's essentially the concept. Let's actually put in some code for that. Okay. So the first thing we need to do is we need to go into our player class, and we need to figure out like what we're actually going to be colliding with. Like, we need to figure out what things we're going to be colliding with. So in our update function, this is where we're going to do all our collision calculations. So if we look in our update, we're taking in one parameter right now, which is delta. Let's take in one more parameter, and we're going to call this tiles. So this is just going to be the set of all tiles that we need to consider for calculation. So that means we need to actually input that into when we're updating our player. So if you go to your game.py file, we have update, and we look for our player update, we need to put in self.tiles. Okay, go back to your player.py file and just delete everything in here. Okay, we have to basically like rewrite all of our collision from scratch now. For one reason, it's because you won't. It doesn't seem obvious at first, right? But you would normally think that, okay, why don't we update our player? And let's say he's like moving at an angle, like he has an x component right here. This is your x velocity, and we have a y velocity, right? Y velocity. Why don't we just like add them at the same time, right? Because we can do that, right? But what happens if we're going like this and we were to hit an object right here, right? Like the next frame, we'd put our player right here, right? Where do we like sort this? Like, does he go here? Does he go here? Right? There's no way to know, like, for these corner collisions. So what we do is a little trick that I learned, right? Let me just like erase it there. I just like make a new one. File new. Okay. So what we can do is we can, if we have our player here, what we do is first we check the x. Can we move in the x direction? If yes, like if our object is right here, if we can move this way and we're not colliding with it, then yeah, we'll move it to right here. And I'll just continue this out here. Now we will check for the y. Can I move down to the y? And in this case, yeah, I can move I cannot move down on the y. So that means that we've sorted our collision to be out here. Now you might be thinking, okay, but it could be the same thing for moving it here and here, and that's just like one of the unfortunate like outcomes of it. If you have like a really laggy computer, your like these things can be really big. Like your the amount of distance you move per second is gonna be like not per second but per delta time, right? If you have a crappy computer, your delta time is gonna be way up there. It's going to be a lot of time to compute a frame, so that means you're going to end up moving a lot every delta time. So that could cause a problem if you are having delta time, but generally it's imperceptible. Like the amount of distance that you're moving in reality is like really small. Like let's say this is your player, right? You're probably only going to be moving about like this much every frame. Okay, let me zoom in on that. I can't even tell what this is. Like, you're probably only moving about that much and like that much down. So it's really imperceptible. So it won't be a problem for you. So, let's actually do this now. First things first, we need to decide like what's gonna happen. Like, if you hit a block like head on in Geometry Dash, so let me like just draw a level for you. Like let's say this is a block and we have our player right here. if our player like smacks his face into this wall right here, then he becomes dead, right? That's game over for you. But if he goes onto the floor, or he collides with the floor, yeah, we want to put him like right on top of the floor so he doesn't collide through it, okay? And when we jump, right, we want the player to be able to land on the floor and not like phase through it, right? So one more thing, if he hits the ceiling here, then that is also results in a game over. So if he hits a ceiling, like this is a block right here, and he hits this ceiling, that means game over. Hits here, game over, right? And you don't need to worry about this side because the player is never going backwards, so he can never hit this side. So yeah, and I believe that covers all the cases. So let's go code that now. So for each tile in the tile list that we've been given, we're going to check if we are colliding. Check if we are colliding with the tile. And then we want to say, okay, yeah, if we're going like straight forward into a tile, then like if we're ever like inside of a tile, then we probably are game over. But we need to actually make a function to check if we are colliding. So let's make a function, and we're going to call it colliding. And it's going to take in a parameter. This parameter is going to be x, y, width, and height of the other block of the tile, because we already know our width and height and position already. So what we can do is check if we're colliding. So if self.position.x is smaller than x plus width, and self.position.x plus self.width is greater than x. Okay, this is only half of it, but let's review it. So we have self.position.x. So we're saying that let me just make this smaller. So we're saying that if we have our square, right? I'm just gonna make it red for you guys. So this is our square, and we're saying that if we were to have another square, right? Like let's say there's a tile. So this is a tile right here. So if our position.x, self.position.x, which is referring to the player, so that would be this corner right here. If that is smaller than this one's x plus the width, so this line right here, right? So if it's smaller than it, okay, we're going to consider it. So we're considering it in this position because this is smaller than this. We're considering it in this position as well because this line here comes before this, but we're not considering it when it's over here, right? Because this one is smaller than this. Okay, so that's going to be the first check that we do. Now we've already eliminated any tile that's in this area here, right? But we still have tiles that could be over here, and we need to check that. So if self.position.x plus self.width, so this line right here, this axis, we're going to check if it is greater than this one's x. So that's going to eliminate this one, right? Because this one has a greater x than this one. But if we move it here, right, this one is already canceled out by this first one here. So that means that we know that there's at least one axis of collision. So this works. This doesn't. Oh, this does, sorry. Like this is passing in one axis up here. This is also passing in one axis. So we need to do the same thing for the y. And let me just write that out quickly. Self.position.y is smaller than y plus height, and self.position.y plus self.height is greater than y. Okay? So that's basically the exact same thing. So position.y is this line right here, is smaller than the y plus height. So this is disqualified. This works, but then finally self.position.y plus height, so this line right here, it has to be greater than this one's y. So the only one is if it's colliding. We have two axes that are being colliding with, that are overlapping. That means that we are colliding. Like this is not colliding, this is colliding, this is not colliding, this is not colliding, this is colliding. Okay? I hope that makes sense. If you guys have any questions, please let me know. Alright. You can type out your questions if you like. I don't think we have any questions, so I think we got it. Okay. Here it is, colliding. So if all of these conditions are true, return true. Yes, we are colliding. Otherwise, we want to return false. No, we are not colliding. Okay, now we can use this when we're checking if we're colliding with the tile. So if self.colliding with the tile.position.x, tile.position.y, tile.width, and tile.height, we would do all these checks as before, and we've determined, yes, we are colliding, and we want to return player dead. We are dead if we are colliding with a tile like that. Now let's do our y movement. So the reason I didn't put like self.position.x plus equals self.velocity.x is because we're never going to have an x velocity. It's always going to be equal to 0 because our player is always going to be at the same spot, and we don't have to worry about him moving like forwards and backwards. But he can be moving up and down, like if you do a jump or if you like fall down, then the player is going to be moving on the y. So we do need to actually do this for the y. So what we do is self.velocity.y. We're going to add self.acceleration.y times delta. These are all in your kinematic formulas. Physics class, hopefully you guys remember them. You don't need to remember them. I just remember this. Self dot, like every time we change delta y, right? This is essentially, let me actually like show it to you like in a paint. So if we say that dy, we say d is equal to v1t plus half at squared. Okay, so we're basically this this one, right? This one was our old velocity. This should be v, right? I think. Wait, no. This one is d equals v1t plus at squared. Right, this one is your previous velocity from before. Right, this one is time. So at, that just becomes vt, right? I think I might have got this formula wrong, maybe. I don't think so, right? But you're basically just adding in from the old one. Let me restart this actually. Okay, so we know that your acceleration. Let me just actually pull out my formula sheet. Okay. So we do know that the acceleration is just the change in time. Sorry, the change in velocity over the change in time. But we're just keeping our acceleration constant for now. So that's just gravity. Right, but our velocity is using the equation to determine the velocity, right? That's just the change in acceleration over the time, right? So if we have v2, so like our new velocity is basically just our acceleration, like how much our acceleration has changed, right? The rate of change of velocity is our acceleration. We're just multiplying that by the time. So delta acceleration, right? And your position, d, that is the rate of change of velocity, right? Times time, right? Velocity is pixels per second times time. So hopefully that makes sense. If we take our position dot y, we do self dot velocity dot y times delta, and that will give you your parabolic motion. And then one last thing, we need to set self dot on underscore ground is equal to true. So this is just a variable that we're making to determine whether the player is on the ground. So initially the player is not on the ground, but if we collide with the floor, then we're saying, yeah, we're going to be on the ground, right? So we're just assuming that we're on the floor, but if we're not on the floor, then we'll just set it to false, and then we don't need to worry about it. So we're going to loop through each tile, right? We're going to check if we're colliding. Tile dot, I can just copy this line here, right? And then if our velocity dot y is greater than 0, so that means we're going down, right? That means we're colliding with the floor, right? Because like the direction that you're going, that determines like if you're colliding with the floor or colliding with the ceiling. Because you can't be colliding with the ceiling and have like a downwards velocity, right? You can only be going upwards. That way you would be colliding with the ceiling. So self.position dot y, and we're basically just going to be fixing the position so basically we're just like setting our y position to the tile's y position, and we're subtracting our height. Let me draw that. So we have the floor here, and we have our player. If he's colliding with the floor, right, then we want to set our y position, so this right here, we want to set it to the player's height, so that's the player's height, and right here above this point, right? And that can be for any x, like x could be over here, x could be over here, right? At this point. This looks kind of like some kind of artwork, I don't know. Anyways. And one more thing, since this is for going down, if you're going down, you must be colliding with the floor. So on the ground is just going to remain true. Sorry, we're assuming that we're not on the ground. Otherwise, if we are going, if we're going up, so our velocity y is negative, that means that we are colliding with the ceiling and we want to turn player dead. And we can just do like kind of as a courtesy, just to set the tile dot, just set the player's position so it's not clipping. So in case we have like kind of a death screen, like or a slow-mo replay, like it'll just show the correct position instead of like glitch into the tile. So yeah. And lastly, we just need to, you might notice that we've checked for if it's greater than 0 and smaller than 0, but we didn't check for 0, right? But if the y velocity is 0, then it's not moving up or down, so it can't be colliding with anything. So we don't need to worry about that. And after we collided with something, we just set the y velocity to 0. Just so we don't get like any stuttering or anything. Okay, and with that, we're done collision. And there you go. It works. Okay, so that will be it for this meeting. Hopefully you guys enjoyed that and learned something new. So if you have any questions, you can ask them right now. And raise your hand or type something in the chat. Okay. I think we're good. So I'll post the video on the Google Classroom, and you guys can watch it if you want to review. Otherwise, we'll see you next week, and yeah, have a great week, guys. Goodbye.